Hi everyone. When I was 7 years old, my parents bought for me a chemistry set. You know, the ones with those tiny chemical compounds, the test tubes and the Bunsen burners? For one entire month, I was completely obsessed by the chemistry set. I must say, quite a few times I nearly started a fire in my bedroom. But that chemistry set actually helped me to decide to embark on a career that not only requires innovation, encourages innovation, but also requires it. You see, in the AWS prototyping team, we actually help customers to develop prototypes to bring their innovative ideas to fruition. It allows us to go with the customer to breed to be embedded in their organizations, to have a culture of experimentation, to be able to push the boundaries of what is possible, and also challenges us to learn and be curious. So with that in mind, I'm here today to talk to you about a prototype that we built with a customer that ended up bringing them real business value. Being a level 400 session, I'm not going to have the time to go through exactly what a large language model or a RAG is. We do have a lot of resources online and a lot of other sessions that you can attend to actually get this information. So I'm just going to delve straight into the use case of the prototype that we built. This specific customer had obligations around ESG reporting. Now, some of you might have heard this term. It stands for environment, social, and governance. It essentially means, or essentially is a framework for, or criteria of how an organization is able to be measured against aspects like climate change, sustainability, how it interacts with its employees, and as well as senior leadership. So this customer that we had essentially had a team of analysts that was spending up to 30% of their time going through reports manually, looking through various data sources in the organization, and also spending time writing a lot of SQL, because they had databases in different places in the organization. And these analysts, some of them may not have had a lot of SQL experience, so that was really slowing them down as well. So we were trying to build for them an ESG reporting prototype, which helped them to both search for data wherever it might have been, as well as generate SQL queries for them. Now, in the following few slides, I'm going to show you a demo that might seem rather simplistic, but there's a fair amount of things that are going behind the scenes, which I'll explain in a bit. Okay, so first we have a chat interface, and I'm going to be asking the chat agent some basic questions around ESG, like what are some of the guidelines around ESG. And this is a pretty standard RAG implementation, so it should be able to just get back the results. Now, it's also able to perform source attribution. So it's also able to tell us exactly where it found the data, and also which page it actually found the piece of information that we are looking for. Okay, so this is a PDF file where it actually got the data from. Next, we're going to ask it to generate some SQL for us. So I want a query to be able to get all the gas utilization for the year 2020. And it's able to do that because it understands the structure of the tables that it's trying to generate the queries from. In order to be able to route between these multiple RAGs that are powering the chat agent, what we actually did was create a logical construct called a workspace. Now, this workspace was a combination of prompts, the model, as well as the actual data source to actually grab the data from. Now, you see that in the prompt, we actually have a few curly braces, and we have the workspace ID. So what that essentially is actually for us to inject or create the prompt at runtime using an open source framework called Handlebars. So what happens is the prompt gets generated, It loops through every single workspace with the details and then makes a determination on which workspace to actually route the question to. In order to do that, we came out with the concept of content hints. So these are hints that we pass into the prompt to ask to let the model know where to actually route the data to. So, to route the question to. So in my example here, we have a content hint telling the model to, for any question around unstructured data, policies, guidelines, procedures, route it to my unstructured workspace, which is essentially a RAG. For any structured data or for any SQL queries, any specific statistical data, I want to route it to my structured RAG. How the unstructured RAG looks like, essentially is a very basic prompt with a context and a question, as well as the PDF files where it references to get the data. For the structured RAG, we upload an SQL schema file. This is essentially the DDL script that is used to create the tables. Now this allows the model to infer the column names and the data types to be able to construct SQL statements on behalf of the user. In order to build this, we created a prototype with 3 tiers. The first one being a presentation tier, model tier, and the data tier. The presentation tier was fairly, it was a standard serverless implementation, a React.js website on Amazon S3, calling a REST API on AWS API gateway. And with the model tier, we had our models hosted with Amazon Jumpstart, or Amazon SageMaker Jumpstart. And with on the data tier, we had AWS step functions performing the orchestration of RAG tasks. For example, retrieving the data, generating embeddings, and storing the vectors in a Postgres database on Amazon Aurora using the pgvector plugin. Now, a lot of you here might be sitting here and going, that's great, but what value does this have for me? Now, you notice that I mentioned that we use Amazon SageMaker Jumpstart. And today, we have Amazon Bedrock available in Sydney. So what I'm trying to get, what I'm trying to actually let you get out of this session is to actually show you how you can actually recreate the prototype that we built in a very short period of time by using the services that we have available today. Again, level 400 sessions, so I don't have time to go in depth to all the services. But essentially what we'll be using today for this very, very, very compressed prototype is Amazon Bedrock agents, knowledge bases for Amazon Bedrock, essentially, which is essentially a managed implementation of RAG, which abstracts away a lot of the tasks for us. Secondly, we'll be using Amazon Bedrock agents, which helps us to orchestrate the knowledge bases as well as action groups so that we can actually automatically call APIs from Bedrock agents. Lastly, Amazon Q for Business, or Amazon Q Business, which is a generative AI assistant, which allows us to perform tasks like content summarization, generate summaries. It also allows us to connect to a whole myriad of data sources within your organization. You see, customers have told us that it's very unlikely that you will have all your organization's data in a single place. It's unlikely that you'll just have one single S3 file in S3 that's going to encompass all your data requirements. Hence, we have Amazon Q Business allows you to connect to various data sources in your organization to get the data where it's needed. So, for example, you might have a lot of tribal knowledge in Slack. You might have documents stored in Microsoft SharePoint on-premise. You might even have documents in Box box.com or Google Drive that you need to get access to. So there's a lot of connectors that Amazon Q Business can actually get access to your data from. And that is very valuable. But what's even more valuable is how about letting our Bedrock agent connect to Amazon Q, which will give the user a seamless way of getting access to all that data. So we're going to show you that. I'm going to set the scene for the demo. Again, I'm going to reprise my role as an ESG analyst. I want to know what ESG is, what compliance obligations I have around vehicle noise emissions. Since we last talked 5 minutes ago, my SQL skills have not improved that much, so I needed to generate SQL queries for me. And lastly, I want to go beyond just asking questions. I want to go beyond just retrieving data. I want to be able to write to an external database because I have, for example, I might have noise emissions testing results that I need to write to a database. So we want to do that as well. 4 things that I'm going to show you in the demo. First, we're going to be mixing structured and unstructured data, similar to what we did just now. I'm also going to show you how you can surface the chain of thought and agent prompts via the Bedrock, by Amazon Bedrock agents, so that we can know how the how the model is actually performing the routing of questions to various knowledge bases and action groups. We're gonna be integrating with Amazon Q Business, and I'm going to show you how we can submit noise emissions data testing data for vehicles. One thing to note, everything that you see today, everything you see in the demo, I'm going to be showing you in the management console. However, you can also, everything that you see here, you can also do using infrastructure as code with CDK or CloudFormation. All right. Okay, so we'll go to the Bedrock Agents console and create a new an agent. So I've created an agent there called ESG agent. Sorry, it's not playing. Okay, now it's playing. Okay. And then we go into the agent, and under the agent details, I've actually provided instructions for the agent on how to react to various types of questions. I'm also allowed, I can also select the model that I want to use, and I've also provided it some few short prompting examples so that it knows how to respond to the questions. The next thing I want to do is then create the 2 knowledge bases, one for structured and one for unstructured data. So I'm going to go to the knowledge bases page, and there we have our structured data and our SQL schema, which is going to act as our structured data knowledge base. So let's go to unstructured data first. And essentially, for unstructured data, I have the same set of PDF files stored in Amazon S3. And it is within these PDF files we're going to get the data from. Now, at the bottom, you see here that Knowledge Bases has actually created a vector database for us using OpenSearch serverless. And it's also created embeddings using the Amazon Titan G1 embeddings model for us. So all that, you don't have to do yourself. It's, comes as part of knowledge bases. Okay, next we're going to look at how to then set up structured data. For this example, I've uploaded a DDL script, which actually lets the model know how my tables are structured. In a real scenario, you might be using this to connect to Athena or some other database on RDS. Okay, going back to the agent, let's test it out. So I'm associating the knowledge base with the agent. And each association, you can actually create instructions so that the agent knows which knowledge base to route to. Okay, so we've got 2 there. Let's give it instructions on which knowledge base to actually use to answer the question. Now, for the sake of the demo, I'm going to actually disable our structured one first, and let's see how it answers some questions. Let's prepare the agent. And I'm just asking it a basic question. What are some important ESG guidelines? Now, I should be able to answer this pretty easily because it's just coming out of the knowledge base. Yep, so there you go. We get the answer pretty easily. And then now we're going to ask it to generate an SQL query for us. So once again, I want to be able to generate an SQL query. I want to know all the total costs of gas utilization for my whole organization in 2020. Now you'll see that the agent has declined to answer the question, and the reason, of course, is that we have disabled the knowledge base. And Bedrock agents guide rails has prevented it from hallucinating on any information that it doesn't have. So let's re-enable it and prepare the agent, and then ask the same question again. So yep, so this time it was able to generate the SQL query. Now, not only able to generate a simple select statement, you can actually see it's actually done an inner join with a different table. It's also done an aggregate function, a sum on a column. Okay, so number 1 done, right? Structured, unstructured data, we've shown that we can mix it together. All right, now second one that we want to do is to, sorry, that was number 1 and number 2, we generated the SQL query. So we want to be able to submit the decibel reading for a vehicle that we've done sound emissions testing. Now to do that, I've created an action group and uploaded an OpenAPI definition file. You'll see that in the OpenAPI definition file, I have a submit decibel method or operation, and under that I have a description called submit a decibel reading for a vehicle. Now the cool thing about this is that Amazon Bedrock agents automatically infers when to actually call this operation based on the context of the question. It also discovers the request and response as well. I'm going to show you then how the Lambda function that it actually calls as part of this action group. All right, so this Lambda function is just a very simple Python Lambda function. All it does is it takes a request, it unpacks the request, and sends the response back, the information in the response. In a real-world scenario, you would be connecting to a database or call an external API with the information that you have. So let's go back and try out the agent. So I want to submit noise decibel readings for a vehicle. You see that the agent has actually asked a follow-up question to the user. Now, I haven't done anything. I haven't coded anything. I haven't had to do any configuration. The agent has inferred that it needs that information to call the API by itself. It's also asked, now it asks for the vehicle identification number, which I provide. And there we go. We have the submitted decibel reading for noise emissions. Okay, so that's use case 3 done. Now let's take it, for example, I don't know whether 92 decibels is good or not. So I know that there is a regulations report or emissions regulations report or guidelines available. And I know that my company has uploaded it to Amazon Q. So like this document basically is government guidelines on vehicle emissions. And I know it's in Amazon Q, so I want to get access to it from Amazon Q Business, but I don't want to recreate, the document in a knowledge base. So going to Amazon Q, I'm able to look at the application that we built in Q, and I have an uploaded file. So I've uploaded that file directly into Amazon Q, but you could just as easily add a data source using any of the 40 plus connectors that we have in Amazon Q to actually connect to the data that you need and retrieve it. All right, going back to the agent, I'm creating another action group to connect to Amazon Q. And once again, uploaded an open API definition files. And this time telling it that, for this API, I want it to provide, or I'm using it to provide responses for noise emission standards. So this is how the agent actually knows, call this API to know about noise emission standards. Let's give it a go. Okay, came out with the result. How do I know this actually came from Amazon Q and not any, it wasn't hallucinating or anything like that? So what we can do is use the trace functionality that comes with Bedrock agents, and we actually get a lot of observability from this. You can see that at the bottom here, it's actually provided us a rationale. So Bedrock agents has actually provided the rationale to go, okay, you're asking about emission standards. It seems like a reasonable question, and this is the API operation that I'll call in order to get a response for this question. Now then, in order to do further diagnosis or debugging, you could go to the orchestration tab and look at the format or the structure of the request and response from the Lambda function that is linked to this action group. So we can see that the response from the Lambda function, and that's provided the emission standard information that we need. Last bit here, I'm just going to go through how that Lambda function looks like that connects from Amazon Bedrock agents to Amazon Q. All right, so again, a very simple Python Lambda function. And what I'm doing is I'm using the Bodo 3 client for Q Business to connect to Amazon Q and send it the application ID and also the actual question that the user asked and returning the response. Now you see that I've hard-coded for this, the sake of this demonstration, I've hard-coded the employee user ID. But in a real-world scenario, you would probably integrate with some identity mechanism like AWS Identity Center to actually pass that information to Amazon Q to do some form of role-based access control. All right, that's all 4 down. So I've gone through quite a lot in a very, very short period of time. I just want to kind of summarize my thoughts on what we've done. About 18 months ago, we started to see generative AI start to become mainstream. When it first came out, I think a lot of people were using it to, for entertainment, for humor, using it to generate emails, a whole bunch of other use cases. But fast forward to today, in prototyping, we found that, companies are starting to use it to derive genuine actual user business value from generative AI, whether it be improvements in operational efficiency or cost reduction. We're seeing a lot of companies actually start using that. And you also, in your organization, you're probably also starting to see the advent of generative AI in your companies as well. Now, having a single RAG to query against is still, it's really useful. But what's really useful is the ability to then perform orchestration across different RAGs. You've got multiple RAGs that you want to use at the same time. You also got action groups that you want that can actually help to perform actual tasks. And bringing that all together actually amplifies the utility of generative AI. customers have also told us that flexibility and extensibility are important, and they actually bring a lot about velocity. Not having to tightly couple ourselves to any specific models, and as we know that models are coming out, pretty much every 2 or 3 months now, and also being able to be flexible on prompt engineering, all these go a long way to actually speeding up the pace of development, as well as providing speedier business decision-making capability. In 11 minutes, I essentially showed you how to build a Bedrock agent that can do both querying from multiple knowledge bases, connect to Amazon Q, and also be able to submit data. In the past, where you had to do a lot of this heavy lifting yourselves, this would probably have taken you a lot longer. So now that Amazon Bedrock is in Sydney, I'm really interested to know whether you guys can do your prototyping in a lot faster way using these managed services. I'd like to before I go, I want to show you I want to leave you with some builder tools that we have. The first one is AWS Project Development Kit, or as we call it, PDK. We found that in prototyping, every time we do a new engagement, we found ourselves having to do a lot of common scaffolding work, having to do a lot of dependency management manually, having to create monorepos. And the AWS Project Development Kit was launched so that we could abstract away or do all that for us automatically without us having to do a lot of that plumbing work over and over again. So it has been open sourced. Feel free to use it for your own projects if you want to. The next one is our conversational RAG reference. We've lovingly named it Project Galileo, but yeah, you can use this conversational RAG reference. It's open source, and you can easily just deploy it straight into your AWS account and start using it. Start using a RAG immediately. The last one is a Party Rock agent code generator. I love this. The reason is because just now I showed you all the OpenAPI generators, OpenAPI definition files that I had to add in for the agent action groups. This Party Rock agent code generator allows you to generate those OpenAPI definitions. It generates Lambda stubs, generates the Lambda test payloads, all using natural language. So you don't actually have to do the manual lifting yourselves. In 11 minutes, I blitzed through a lot of services and information. So I highly recommend, if a lot of that was too much to handle, please check out our AWS Skills Builder platform. You get access to more than 600 courses for free, and you can also get access to our AWS professional certification exams, the official sample exams for our certifications. Now, lastly, just want to thank everyone for coming, and please feel free to add me on LinkedIn. I'm really interested to know what kind of projects you guys are doing in generative AI, and yeah, please hang around and come and chat with me. And yeah, otherwise have a really good day and really good summit. Thank you.
Please keep that applause going, please. Elgin Lam, fantastic session, well done.